my name is Max Boksem. I am a student at University of Amsterdam. I'm currently doing my master's program. I'm pretty close to finishing. But yeah, I'm going to give a talk today again for my paper, Bridging Incremental Programming in Complex Software Development Environments. So the kind of the motivation behind this was that there's, I feel there's two kind of key software environments that most developers are kind of utilizing nowadays. The kind of traditional one is the text-based IDE environment, so whether that be VS Code or even stuff like Vim. Everything's very structure-based, everything's located in files, and as well the code in general is kind of scoped in an aspect like this. But then you also have kind of, because this is the norm, and by far most software companies are utilizing this, you have also a lot of community, if it shows, a community kind of extensions that can kind of be built upon this to kind of, get more understanding of the complexity of the actual software system themselves. So the other side of this that's really coming into gear now is kind of the incremental programming environments, like which I will say. And that kind of involves REPL-based environments, and as well, kind of going on top of that, computational notebooks, like you see in Jupyter Notebook. What's really key about this is kind of the incremental approach from this, so it's very iterative. And you're able to really kind of explore and experiment with different types of code fragments as you're going through the development process. So what I was kind of thinking was, how can we bridge these two environments to kind of abstract this incremental aspect and kind of exploration, and as well as really trying to grasp the complexity of big software programming environments. So the idea we had in our head was kind of put this in a graph structure. So basically, instead of cells you have in a Jupyter Notebook or REPL, you have kind of independent nodes that are in charge of their own programming. And then you kind of have the structure as well embedded in it based on relationships. And you can maybe even classify different nodes as potentially meaning separate things, for instance, class nodes or code fragments or method nodes, and they all can kind of have a big picture of what things should be representing. So yeah, that brings me to kind of the prototype that we developed. It's called the Incremental Graph Code, IGC. It's a bit small, but yeah, it's really kind of an environment built upon these fundamentals that we just mentioned. So yeah, I'll talk more briefly about it. I don't want to go too into the details about like the technologies that we made, but currently we just did it as a test case. It's supporting Python, and it's very, the idea is to make this very extensible and to have kind of a community build features and different nodes and different relationships behind everything. This is a little bit cluttered, but kind of it gives you a picture of all the things you can kind of represent, whether that be dependencies or executions or documentation nodes in general. So kind of the idea when developing this was to have a couple of case studies that we want to perform. So completely on the incremental programming side is how can we kind of represent a computational notebook directly in this environment itself. And this is also kind of idea as completely on the opposite side. So the kind of the IDE understanding or the environment on, could we really encapsulate that? But these were the 4 case studies. It's a computational notebook, which we prioritize in the paper that we'll show a little demo of. We'll also try to do like a protection. I think I spelled this wrong. But yeah, it was kind of inspired by Pascal J from the previous year session. And then there's also kind of a compositional or architecture view that you can kind of rearrange the nodes in a way that almost resemble maybe some UML diagrams or class diagrams or something like this. And then as well, further going on that is kind of the exploratory view where you can mix and match different kind of executions and kind of compare different nodes. So that brings me to kind of the demo. I have a video demo that I'll kind of talk over, if this is playing. So this is kind of initializing the environment itself. I just call it test IGC. So when you create this, a IGC file, then you have kind of this blank workspace. So right here, I create a node, and right here is kind of like the list of nodes I currently have, but we're just going to test with the code fragments. I can rename it kind of here, and then I just do a quick refresh to be able to, let's do like a quick test for code to actually embed that in the node itself. So I do a quick, this is a test Python script. But then let's also make a documentation node or some markup that kind of is associated with this node. So this takes any markdown text, and then when you actually click on the node itself, it shows above the code snippet. So now I built like a little bit more of a complex system already. That was actually shown in the showcase I have in the paper. So everything is kind of already pre-built in. But if I want to execute anything, nothing will happen until I make a session. So all the executions are kind of gathered all in what's called, well, I call it a session. It initializes as kind of like an empty set, so nothing happened. But when now I try to execute the code itself, you have this little relationship arrow that comes out from this very, how we call it, start node. And then you kind of can see all the output and the errors and the configuration, or like the data that comes out of it. Because there's no print or anything, there's no errors, nothing's really going to show in the output. But you can continue kind of branching off from this initial node to create like any kind of program that you potentially want to create. And it kind of compounds as you're building this, this program, and as you can see on the very left side. So this is everything executed all in once. I also created another session, but that's kind of behind the scenes. But you can see kind of the output at the very end is encapsulated from all the previous nodes that, that executed itself. Yeah, so maybe there's a use case where I want to try inputting different input data. So I execute kind of this sub-branch based off of the initial. And then I can kind of see the data that kind of changes between this new input data that's kind of all feeded back through this system. This was not shown too much in the paper, but this is kind of a projectional view that shows basically the entire Jupyter notebook based on the actual execution projection that's here. And you can also just categorize it directly by documentation. So if you only want to see documentation, you can do that. And then you can also just show the code itself. And then finally, you also get kind of the configuration at the very end on that. I also show, I believe, kind of another view that dictates kind of the two different branches that are embedded in the system itself. So you have the input data 1, input data 2, and then you kind of have the raw data that's encapsulating the entire environment itself. So that's the demo I want to show you. Oh, it's reloading, it looks like. Yeah, I'm not going to go too deep into the program because I'm already way over time, but that's there. And then some kind of related work that a lot of this was kind of inspired by or has a lot of similarities to. So that's it. Thank you very much for listening.
Thank you. So let's start again with the boring part. Summarizing. What did you hear? What did you see? But it helps sometimes to rephrase it so so that the speaker can see, okay, what did you actually hear? So I saw an IDE and with some visual programming, then some traditional programming connecting several views, and it looked more like an Visual Studio IDE than like a Smalltalk environment, probably because of the window management, but I don't know. So just some. Okay, Mauricio.
Yeah, so I think also based on the last examples that you showed us, I think the paper it's really interesting because it allows you to build different types of incremental programming environments, as you call them. And I think, for instance, the notebook view that you showed and having the possibility to just see the documentation. Sometimes you just want to see the documentation. I think this is a very interesting approach to build these custom notebooks or behaviors and not just the rigid Jupyter notebook structure.
Yeah. This projectional view was very based off of this Pesquet paper that was introduced last year.
Yeah, now we can also see the Discord. The two Discord faces. Tom, what did you see?
Yes, I think it's really interesting that, or rather to summarize what I heard, the authors put the sort of tension between a full programming environment and an incremental programming environment, and then try to reconcile the design through this idea of the graph structure, which makes the execution flow explicit in this session concept. I think those are the main takeaways for me.
Thank you. Then let's switch to the second part. So what did you like about the project? What did you wish to see improved? What other comments do you have?
So I did like the way the authors looked at the tools we use to program and also to support different kinds of activities, like ranging from exploratory programming supported by REPLs or notebooks to more traditional software projects toward just regular applications. And also based on that, just looking at the properties we would like on both ends of the spectrum, and trying to figure some requirements to just combine them in a joint tool chain, maybe. And in particular, from the technical point of view, I like the idea of making sessions explicit of first class, and with that helping people from the notebooks community to make their computations reproducible, repeatable, and also comparable. So I think the sessions stuck out for me as one of the main contributions.
Yeah, I also really like the sessions approach, this like generating the execution traces. And as somebody from a Lisp background, I wonder, like, yeah, if you should also maybe talk about kind of some of the limitations that some of the, like the Python REPL has, right, where you can't do everything, but there is environments where you can. And yeah, maybe some suggestions for other related work. So I also work on a computational notebook with incremental computation for Clojure. It's called Clerk. And there's maybe Streamlit for Python that's also similar, and Pluto for Julia.
Tom, can you hear us?
Were you talking to us? Sorry. Okay. Yes. So the 2 points that stuck out to me, as I mentioned already earlier, the execution order, and I think it was especially interesting in your related work. You talked about observing.
Sorry, we can hear you.
Saying that solving this generally, this idea of modeling these dependencies and the update change that then arise is too difficult, and thus you modeled it explicitly using the order that people execute the cells in, right? So I think this tension between trying to support something general and thus not doing it in a sort of principled manner, but asking the user to derive things is rather interesting here. But I'm still a bit.
You're frozen again.
Can you repeat the last two sentences?
Can you
repeat the last? Okay. The sessions concept is not 100% clear to me yet. How exactly it interplays, like when you change sessions, if I can clean up sessions, how I share them. But I think those are maybe also questions that are in your future work.
Rimmer, did you want to say something?
I like this approach. Very well presented, Max. I also like this paper. The idea of what you're showing here is, in my mind, ringing like a debugging view on notebooks, and so they could like relate to omniscient debuggers, or maybe like a generic.
You're frozen again.
Ring as something negative, because there are certain approaches that didn't work, including from the Godot engine that I like very much. Like there is a visual language in there, an old one they removed. I use their visual frameworks now to make DSLs. But not everybody enjoys these types of representations. But if they are optional and offer the users a particular way of interacting, then I suppose that might work. But yeah, I'm actually curious to see how it will be applied more in practice. That was my comment. Thanks.
Yeah, no, I mean, that's also, it's very hard to have people transition to a new environment when they're very familiar with their own original. So the idea is to kind of have this approach where users from potentially are very familiar with computational notebooks or are very familiar with IDEs to try to have features and try to have this new hybrid environment suitable to, if you only really want to do these computational notebooks, you have a way to do this. If you only really want to focus on kind of more this IDE approach, you could potentially just create a node and have all your file structure or all your content exist in this node, and they can interact still with different files and imports. So yeah, there's a big kind of consideration on this point. Another something in the future work is actually to be able to export back and forth potentially between these different environments, and as well, the other way to go into this new environment to kind of bridge this transition, hopefully.
Thank you for the presentation. I think like whenever we find issues in the programming issues in just the programming ecosystem, I feel like a lot of PL researchers tend to focus on the language and the semantics and the syntax and like ways to improve the language itself. But I think like we often neglect, I guess, the tooling and the ecosystem and the editor around it. And so like any research that advances and experiments with like new ways to edit, I think is extremely exciting to see. Something that I always have in mind when I see these kind of things is that whether like the technology for incremental compilation and those technologies have like advanced enough that we can actually just embed this, because I feel like the idea is extremely cool, but as like if I imagine like really big projects with a lot of dependencies and with a lot of imports and a lot of code, I think like it might take a while for like all the graphs to update and like all the code to compile, and so like it might not be as smooth of an experience trying to like expect like a REPL like incremental development.
Yeah. At a point, yeah. No, I mean like scalability is like a very big issue, and this point was definitely kind of thought across. The idea to maybe kind of combat where you have a graph full of hundreds of nodes is to have kind of a composition node. So potentially have, you know, sub functionality. This can exist all in a separate file, where this file can then be embedded in just a node itself. And so you just execute this one node, and then you kind of continue on as you normally do. Kind of, so your main, I guess, your main file per se, or your main graph, would then be a lot simpler in this respect, because all the complexity is kind of put into other files. You still have this issue, of course, with the actual execution, because you always have to kind of go through all these nodes. But yeah, this is something that has to be addressed with scalability and kind of performance aspects. So.
Any more comments or ideas about the work?
Yeah, so maybe you can explain something about how the session management actually works. So how you have this you have a kind of incremental execution, right?
Yeah. Yeah. So session management basically, I went over it very fast, so it makes sense. It's a little confusing, but basically a session kind of represents maybe a run space. So everything is initialized at this kind of start node. So when you create a new environment or a new graph, you're only left with this start node, and this is representing basically an empty, an empty set. Nothing has happened. But then when you start creating these new nodes, you then can execute only if you're inside the session itself. So you can kind of compare and contrast between different sessions or different executions. So maybe you're interested in kind of running this subset, but maybe you want to do a quick test. So you make a new node, and then you can kind of write a sub, I don't know, a sub code fragment, and you want to kind of experiment on that side. You can then kind of copy that state all over to another session, execute this one node, and see kind of the outcome behind everything. So I don't know if that clarifies a little bit, but yeah, the idea is, yeah.
We have 3 more comments, Tom, Robert, and then you.
Yeah.
Tom?
Yeah, just quickly echo something that Rima and someone from the audience said as well. This idea of having classes and methods on the canvas struck me as a bit surprising, because in particular, it doesn't really make sense in my head, at least, what it means to execute a method node on the canvas. So I'm wondering why it even has to be on there, right? And in the reply that you gave earlier, you also mentioned that you could just include an entire file as a node. This also strikes me as a bit of a dissonance in the way that the canvas might want to be used to show the overview of the project, but now it's hiding a lot of information. So maybe the design would benefit from decoupling those two aspects, execution and sort of the project that backs the execution. But I would also be very excited to be proven wrong and to see that there's actual merit in putting all of this information on the canvas in a way.
Yeah, to go over your first point, the idea behind kind of having these classes and methods was really just the structural aspect. So really to kind of evolve this complexity that you have in the big software systems. Of course, not every language supports object-oriented programming, but that's kind of the aspect that I kind of want to show here, because it's also beneficial, I find, to have these different types of node types and different relationships, and how could we kind of represent it in this sphere. But yeah, in terms of execution though, in the kind of sub-picture I have, what you would normally do is you would first execute kind of the class definition, and then execute kind of the methods that are embedded after that. There's of course probably some way that we could probably, you know, automate, hey, let's execute this entire class. Maybe you put this in maybe a separate file or whatnot, but maybe, you know, there is maybe also a use case where you don't want to execute every single method that exists from the class or so. But it gives you kind of this flexibility to be able to do this, I guess, in the current implementation. Going to the next point that you made, yeah, I agree. Putting all this code kind of in just one node and executing that and putting it somewhere else is kind of defeats the purpose of this complexity aspect that we're trying to solve. There is a feature kind of in the works that is going to analyze the code and maybe try to expand this and into kind of these node types that exist here. So maybe every single code fragment, every expression kind of is split up between code fragments, so you can kind of see this all there. But yeah, it's really, in summary, it's really up to the developers, I guess, will to do or how to formulate this however they want, right? They can make it very simple in terms of the actual development time, or they can make it a little bit more complex where it's really readable and it kind of can withstand a lot more of the complexity aspect.
When reading the paper, it sounded like you wanted to improve not just notebooks, but also REPLs and traditional IDEs. And then also in the paper you wrote that for now you focus on notebooks for whatever reason, and then next steps would be to address all the other areas, like two of them. And first I was curious how things might work out, and looking forward to the next presentations in those other two areas. But then I was wondering if it looks like you pretty much focus on notebooks, and then why not just sticking to that and just focusing on actually the notebooks and improving just them, and not just trying to cover the entire spectrum?
Yeah, it is a very ambitious goal, I guess, to do this. The real motivation to try to cover everything is because IDEs and text environments are kind of seen the norm in kind of traditional software engineering jobs. But the idea is to how can we kind of get a lot of kind of the features and the advantages that you see in REPLs or computational books with this incremental programming, and how can we kind of allow developers in this field that's maybe not as exposed to these REPL or incremental programming environments is what I call it. How can we kind of have them or allow them to feel comfortable in their own kind of IDE text environment, and then be able to utilize a lot of these kind of features that you have. So that's kind of the understanding. It is, yeah, very ambitious to kind of cover these two aspects, because there are tons of kind of things you can do in all these independent environments. But yeah, that was kind of the thought behind it. Yeah.
Hi, nice talk. So what you've really built here is some kind of program meta database, and I'd be really interested in seeing future work that squeezes the juice out of having this information available. Like, based on this remark about concerns about performance as the program scales up, if you have all this information about your program available, it would be very cool if behind the scenes you have all sorts of tricks. So I could imagine you already had an example of these two sessions that have a common prefix, right? You can imagine that with some fancy analysis, it could recognize, okay, I'm going to be doing lots of computation. Again, I could do some kind of checkpoint, and then, for some programs, this would be acceptable. And then when I run the second session, it's actually just continuing from this checkpoint. And you can't do this if you don't know that they have this common prefix. You've already put in the work to, capture this useful property.
Yeah, correct. Actually, behind the scenes, what's happening is that it's actually capturing the state from every node, and it's saving this into kind of a file. So you're able to, in this path, in your example as well, once you have this prefix, you don't really have to recomputate everything that was coming from behind. But the problem with this is that you do have maybe issues where potentially you have a node that comes from before that changes in some way, or is affected. So currently, kind of the live aspect of this is not implemented. You have to kind of execute the entire execution path for this. But no, that's something that's already kind of embedded in the system, and is kind of planned for the future to really harden. So.
Let's thank the speaker again.